Hello and welcome to this video where we're going to be setting up the FMS in the Airbus A320. So by setting up the FMS, what we're going to be doing is we're going to be entering a bunch of navigation data which allows the onboard computers and the autopilot to fly automatically along a predetermined route to get to our destination. So for this video and the other videos for the rest of this tutorial, what I'm going to be doing is I'm going to be following a real world flight. If you have a look outside, you'll notice that we're somewhere different. So we're actually parked at London Luton airports. And we're going to be flying and following real world flight EasyJet EZ153 up to Inverness in Scotland. So at the end of the last video I talked about a lot of the initial cockpit preparation, and one of the last actions that we had to do was to switch on the IRS or the ADERS systems. So what I'm going to do is I'm just going to do that just now. So we've got 1, 2 and 3. And then once that's done we can move down to the captain's MCDU, which is on the left hand side just down here. So once we're down here, pilots would check a couple of things. First, they check the engines on the MCDU to make sure that the flight computers have the correct engines installed. This is quite important for performance information. And then underneath that, in real life, pilots would make sure that the nav database that they have installed on the plane is up to date. And you can check that by the actual date information here and the data cycle number here. Now, for us flight simmers, it is okay if the nav data is out of date. It is not a significant problem. You can still complete a flight perfectly fine with out of date nav data. As I said, this is just something that pilots check in real life. Okay, so let's start setting this up. So for this whole setup procedure on the MCDU, what I'm going to be doing is I'm going to be following chapter 5.4 on page 43 of the documentation that comes with the plane, and that's going to take us through the setup of this step by step. So the first thing to do is to go to the init page. So if you just click on the init button here, that will take us to the init page. Now the first step is to actually enter our departure and our destination airports up in the top right corner here. So what I'm going to do is just type that in just now. So we are currently at Luton Airport. The ICAO code for Luton is EGGW or Echo Golf Whiskey, and then it wants our destination as well. So we do EGGW and then / and then we're going to Inverness, which is EGPE. So once you've entered in your destination departure / destination, just press the right soft key there, and then you see that the screen changes. Now on the screen, if you've got a route which has already been saved or you've done before, you'll be able to select it on the screen. As you can see here, it says none here, so that means I don't have a route currently saved, which is fine. That's normal, don't worry about that. So on the screen, just hit return. And then you see now it has EGGW and EGPE in blue there. So that means the data has been entered in and that's all ready to go. Now after that has been entered, then you can align the IRS. In my last video I did the IRS before anything else, but according to the documentation now you would align the IRS. And as before, you can have a look on the ECAM display and you can see how long it will take for the IRS to align. And then once that has aligned, then you'll see that your two main displays here will sort of go live, so to speak. Next, we need to enter in the flight number here. So as I said, we're going to be following a real world flight. So the flight number for this flight is EZY153. So you just type that into the scratch pad there, and then hit the left soft key next to the line that you need there, and then it just puts in the flight number there. Next we need to type in the cost index. So the cost index is kind of like a performance number for the plane, and I believe in the Airbus it ranges from 0 to 100, but I might be wrong there. So what the cost index does is it basically calculates the performance of the plane. So the lower the cost index number, that means the plane will perform less, so it will climb at a slower speed, it will cruise at a slower speed and things like that. The benefit of that is that you're using less fuel, so it saves money for the airline. If you use a high cost index number, then what that will do is the plane will climb a lot quicker, it will cruise a lot faster. However, it will burn a lot more fuel doing so, which will be a bit more expensive for the company. Flight planners for an airline will have to weigh up the pros and cons. Do they want a flight to get to their location quickly, or do they want to save money and burn less fuel? So flight planners will often, weigh up the pros and cons of a particular flight and then determine the cost index number based on that. A good kind of number, just a general number that you can use when you're flying if you're not sure how to calculate the cost index, is anywhere like 20 or 30. So for this flight, I'm just going to use a cost index of 30. And then after you've entered the cost index, you can enter your cruising altitudes. So I'm just going to choose a random cruising altitude here. Usually flight planners and softwares, again, they consider the weather conditions, they consider the length of the flights. But for this flight, it's a relatively short domestic flight, so I'm going to choose flight level 350. So you can either type in FL350, or you could just type in the flight level there. So 350, and then hit the soft key next to that, and then it automatically enters it there. And that's that page completely set up. There's nothing more that needs to be done on that page. Now the next step is to enter in the flight plan. So to do that, you go down to the F plan button here and click on that. Now I've already generated a flight plan using a website, so I'm just going to rattle through that just now. However, if you want to know how to generate a flight plan, if you have a look, if you skip towards the end of this video, I'll put the time stamp on the screen just now. So if you want to know how to generate a flight plan, you can skip to the end of the video just now and I'll show you how to do that. But for this tutorial, I'm just going to go through and set things up because I've already done that in advance. So the first thing we need to do is we need to select our departure from Luton. So you can see we've got EGGW here. It says we've got a discontinuity. So that basically means there's no data, and then our final points of the flight is EGPE, or Inverness Airport there. So the first thing we need to do is figure out how we're going to be departing from Luton. So if I put my flight plan on the screen just now, you can see that the first waypoint that we have is a waypoint called Olney. So what we need to do is we need to look at the various departures for Luton Airport and figure out how we get to that Olney waypoint from the runway, essentially. So what I'm going to be using is I'm going to be using something called a SID, which is a standard instrument departure. Now if you don't know how to read charts like this or how to figure this out, I'm going to put a couple of tutorial links in the top right corner so you can look at those, you can figure out how to read the charts and figure out what to select there. I'm going to be taking off from runway 26 at Luton Airport. So what I'm going to do is, next to EGGW here, is I'm going to press the soft key. Next, we're going to select departure. And you can see here that it asks us to select a runway. So, as I just said, we'll take runway 26 from Luton. So, select that there. Now it says SIDS available, so it gives us a list of all of the instrument departures that we can select from Luton. Now there's one called Olney 1B that we need to select, but you can see that it's not on the list there. Now what we can do is we can actually go to a different page. So if you use the arrow keys and then press up, you can see that it gives us some more departure procedures there, and they often are listed in alphabetical order. So if we press up again, you can see that we have Olney 1B there. And you can tell when you have multiple pages, because if you look in the bottom right corner, you can see we have an up arrow there, and then we have an up and down, and then we have it down there. So you can see on that when you can scroll through the list of options there. So we're on Olney 1B, so we bring that up, and then select the button next to Olney 1B. You can see that it puts the information in there. Now you can see we have a lot of yellow text there. We have runway 26, we have the Olney 1B there, and we have no transition there. And you can see we have temporary flight plan and temporary insert. So if we hit temporary flight plan, we can go back to the main flight plan screen, and you can see that it gives us some more waypoints listed in yellow. Now we have two options here. We can press this left key here, which will erase that, so it will get rid of all of these yellow waypoints, or we can insert them, so we can tell the flight computer, yes, we definitely want to use these waypoints. So we do, and so we will hit that there. And now you can see all of the waypoints turn green. Now again, on this main flight plan screen, you can scroll through and you can see the different waypoints. So that is our departure set from Luton there. Okay, so now we've got ourselves from the runway up to the Olney waypoint. So now we need to put in the rest of the flight plan. So, according to the flight plan that was generated, our next waypoint will be a waypoint called Welling. And you'll notice there, in between that, we have T420. So that is the airway that we're going to be using. So, on our flight plan here, if we go to Olney and then press the button next to Olney, what that does is that gives us a bit more information about the Olney waypoint. What we want to do is we want to select airways. So we select that, and now we can start putting in the bulk of the flight plan there. So you can see here we have VIA. So this is the airway that we need to enter. So you can see we're going to be going from Olney via the T420 airway, to Welling. So what we're going to be doing is we just type in the airway. So T420, and then type that in. And then we're going to be going to, so this is where we put in the next waypoint. So we're going to be going to Welling, type that in, and enter that. And you can see once we've got that, you can see it highlights in yellow again. So we can either insert that temporary data onto the flight plan page, or we can just insert it directly. Now I'm not going to do that just now. What I want to do is I want to keep entering the rest of this airway information. So the next kind of leg of the journey will be along the UT420 airway to the TNT VOR station, or the waypoint. Now there's two ways we can do this. We can either just type in UT420. After typing in UT420, what we could do is we could type in the next waypoint, which is TNT, or we could use a little trick. So you don't actually have to type in the next waypoint. What you can do is you can type in the very next airway, and then what the flight computer will do is it will figure out, okay, what's the common waypoints between the two airways. Let me show you. So we're going from UT420 to TNT, and then the next airway after that would be UN57. So if I just type in UN57 and put it in here, you can see that the computer automatically figures out, the common waypoint between those two airways was TNT, so it puts that in automatically. So after UN57, we could type in Pole over here, or we could just type in the next airway, which is UN601. Type that in there, and you can see the computer again automatically figures out, Pole was the common waypoint. Use this trick again. The next airway is UL613, and it figures out TLA. So that's all good. Now the final waypoint is a waypoint called Findo, and then it asks us to select a star to fly into Inverness Airport. So at the end of the flight plan there, I am going to just type in Findo just to kind of wrap up the flight plan, and then rather than go into the flight plan page, I'm just going to insert that directly. Now if we scroll through, you see we have Olney, Welling, and then you see we have some waypoints that we didn't have on our flight plan. So these are all intermediate waypoints, and these all get entered in automatically depending on the airway that you're flying. But then you see we have TNT, and then Pole, and then you see we have a couple of extra ones that we didn't have on our flight plan. But we have TLA, and then Findo. So that's all looking good just now. So finally what we need to do is we need to select our approach into Inverness. So if we hit the button next to EGPE, Inverness there, you can see when we left Luton we had a departure option over here, and now that we're getting to Inverness we have an arrival option here. So we select arrival, and now we need to select which runway that we're going to be using. So I'm going to be landing on runway 23, and what we're going to do is we're going to select an ILS approach for runway 23 there. So again, what you need to do is just scroll through to find the correct option there. So ILS 23, we'll select that. Now, normally, if an airport is big enough that it has a STAR or Standard Terminal Arrival Route procedure, you'll be able to select those much like you were able to select the SIDs. Inverness, being a small airport, doesn't have any stars available. However, it does have various approach transitions. So if we go to approach here and go to VIA, you can see that we have a couple of different approaches here. We've got ADN, Bonby and INS. So what you would need to do is you need to look at the approach charts for Inverness to figure out which would be the most appropriate approach. So me kind of knowing what I'm going to be doing with this flight, the best approach that I'm going to take will be the INS approach here. So if I put the approach charts on the screen just now, what that will involve is that will involve flying from south directly over the top of the airport, and then basically following the solid line up to the northeast, and then turning south and then lining up with the runway and landing. So we're going to select INS, which is the Inverness VOR station, and then you see that gets inserted there, and then we go to insert. And that is our flight plan all entered into the flight plan page here. Now, next what we want to do is we want to just go through and make sure that there are no discontinuities. So basically those are any gaps in the flight plan there. And you can see that we have one there between Findle, which was the last of our kind of pre-planned flight path there, and then INS, which is the Inverness VOR station. Now there is actually another way that you can check this. If you go back to the plan mode on the nav display there, you can see that it gives you a north, south, east, west view of your flight path there. Now, once you have that, if you scroll through the flight path here on your MCDU, you can actually see that it kind of draws the flight path with a dotted line. So you can use this just to double check to make sure that the flight path makes sense. It kind of matches what you can see on your departure and your approach charts. And it gives you a sort of a map view of the entire flight. So you can see we're going to be flying in a general northwest direction, and then we're going to be turning a bit more north. Then we hit Findle, and now you can see where we have Findle, the dotted line stops. And then we get to Inverness, you can see we have that kind of approach procedure shape again. But we have this gap in the middle here. So what do we do to get rid of that? Very, very simply, if I come back to this view here so it's a lot easier to see, to get rid of the discontinuity, you very simply hit the clear button so that you have CLR in the scratch pad, and then you hit the button next to flight plan discontinuity there. You can see that we have some more temporary adjustments or changes to the flight plan there in yellow. We do want to accept those, so we do that there, and you can see now that the gap between Findle and INS has now disappeared. And if we come back to this view here, you can see we have TLA, Findle, and then we have the dotted line between Findle and INS there. Now there's one last step that you need to do with the flight plan once you've got everything entered in properly there. So if we scroll down a little bit, you can see that we have some of our waypoints along our departure route here, and you can see that we've got some magenta numbers here. So what these indicate are these are constraints, or these are kind of altitude restrictions along the departure there. Now our airports and aircraft will have these because of noise abatement procedures, just so they don't disrupt the local population, the local public too much. So what we need to do is we need to double check to make sure that all of these constraints are correct and they match what we have on the various charts. So if we bring up the departure charts for the only 1B departure here, you can see that we have several constraints along the departure there. Okay, so you'll notice that on the approach chart here, at the first kind of waypoint there, we actually have an altitude constraint of above 4,000 feet. And then next we have exactly at 5,000 feet, which is a hard restriction, so the plane needs to be at 5,000 feet at this point, not above and not below that. And then you can see along the rest of the departure procedure, we have a couple more hard altitude restrictions there of 6,000 feet. So what we want to do is we want to compare the FMS data to that chart to make sure that everything is correct. So to do that, if we go into the waypoints and then tap the right hand button next to these constraints here, we can double check them. So you can see here that at the Bovington 06 or 6 nautical mile radius there, the altitude constraint is plus 4,000 feet, so that means anything above 4,000 feet there. So that's all correct. And then at the 09, if we check the altitude constraint there, you see it has 5,000 feet. Now you see we don't have a plus or minus sign there, so that means that the aircraft will fly at 5,000 feet at that point. And then we check 6,000 feet. Again, that is a hard limit of 6,000 feet there. And then we check the actual only waypoint itself, 6,000 feet, and again it is exactly at 6,000 feet. So if we wanted to adjust these altitude restrictions, so say it was anything above 5,000 feet at this point, all you would simply do is type in if you use the plus and minus button here, you type in, just press it until you get the symbol you want, plus 5,000 there, and then tap the altitude constraint there. You can see that changes to plus 5,000 there. So that means the plane will fly above 5,000 feet at that point. If you want to put it back in as a hard limit, you just type in the number that you need without the plus or minus sign, and it puts in a hard altitude limit there. And so we do that for the departure and also the approach. So first we check the first kind of stage of the approach there, which is flying over the Inverness VOR. So we need to be above 4,000 feet for that. We check plus 4,000 feet, that's okay there. Now next you can see that actually on this first leg of the approach there, we actually need to descend down to 2,000 feet and then do a level turn at 2,000 feet. So here we have 2,000, and you can see there it says plus 2,000. Now we actually need to change that because we need to be at 2,000 feet at this point. So all we do is you just type in 2,000 there, and into that is a hard altitude constraint there. And then for the next waypoint, it'll be a level turn, so we're going to be at 2,000 feet again. You can see that we're above that on the FMS data, so we just need to tweak that to make sure it's a hard altitude constraint there. And then at 6.1 miles, that's when we'll be intercepting the glide slope, and that's already at a hard limit of 2,000 feet there. So you just have to go through the flight plan and just double check any altitude constraints, just match them up against the departure and approach charts, and just make sure that the flight management system is aware of any altitude constraints there. Now, one additional step that you can do if you are flying manually or you're using radio navigation tools such as VOR stations or ADF stations is you can enter all of the information for those navigation radios on the RAD nav page. So if you just click on that there, you can see you have VOR 1 and its frequency, VOR 2 and its frequency there, and then you can set in your different courses. You have ILS here, and you can also set in your ADFs. Now, because we're going to be using what's called a managed flight mode, so the flight computers are going to be taking care of everything, what they generally do is they set in VOR stations automatically, and then it will use and change between those stations automatically there. So we don't need to really worry about anything for this flight. However, if you want additional confirmation, you can set in ADFs or VORs there. Okay, and once all of that data has been set in, next we need to set up the performance data for the plane. So what we need to do is we need to go back to the inits page. So we click on the inits button there, And then we need to go to page 2. So if you have a look in the top right corner there, you can see we have a left and right arrow there. So that indicates that we can switch between sort of a page 1 and page 2 type scenario. So you go down to the arrow keys here and then you select left and right. So we click on the right page there and then we get onto a second init page. Very simply, all we need to do on this page is enter in the block fuel. So on the flight planner software, that generally gives you an estimate of how much total fuel that you need for the flight. So the website I use calculated the total amount of fuel as 6,121 kilograms. So the Aerosoft Airbus uses metric tons. So what I'm going to do is I'm going to put in 6.2 tons of fuel, which would equate to 6,200 kilograms. And as you can see, I've already entered that in over on the second MCDU over here. And then after you've entered in the block fuel weights there, you can see that it gives us a bunch of additional information. So this is all automatically calculated, and as you can see, these are all fuel predictions there. So you can see that we should use about 200 kilograms worth of taxi there. The trip time there is currently showing 59 minutes. That's incorrect. It's usually about an hour and a half, so I'm not sure why that's a bit out there. But basically you just want to go through and make sure that all of this information is all okay and makes sense. After entering in the block fuel and checking this page, what you want to do is you want to go to the performance page. So you click on perf there and it brings you to the takeoff performance page. So on this page, what you want to do is you want to enter in the flaps setting that you're going to be using. So on smaller runways, you probably want to use a flap setting of 2. On longer runways, maybe a flap setting of 1 should be okay. So for this, I'm going to be using a flap setting of 2. So we just type in 2 there and then hit the soft key next to flaps. There we go there. Now you can see that it gave us our V speeds there, which are all reasonable and they're all correct, so that is good. You can see that it gave us our flex takeoff temperature there, which is the assumed temperature for a D-rated takeoff, which is good. That's fine, that's normal. And then the last thing you want to check is the transition altitude there. So you want to make sure that the transition altitude is correct for this airport. So if you just have a look at the departure chart for Luton there, it should display the transition altitude on your departure chart there. If you need to change that for any reason, all you would simply do is just type in the number on the scratch pad and then hit the soft key next to that. 6,000 was correct, so I'm just going to revert it back there. Okay, and that should just about cover everything that we need to do for the MCDU. So what we're going to do is we're going to get our head back up and away from the MCDU, and we're going to do a couple of final preparation steps before we get on to getting passengers on board and getting the engines going. So first thing we need to do is look at Cockpit Preparation Part 2, which is chapter 5.5 on page 46 of that documentation. Okay, so the first thing we need to do is make sure that the landing system, this button here, is switched off. So that is off just now, that is good. Next, on the EFIS control panel, we want to set the navigation displays to ARC mode, which looks like that. And then it recommends that we set the range to 10 nautical miles, which is the lowest setting there. So that's all set up, that's good. Next, it asks us to set our VOR and ADF radios as we need them. So, as I said, the FMS is going to use and is going to flick between different VOR stations automatically. So, if I just have a look down here just now, you can see that we have VOR. If I can pan across a tiny bit there, we have VOR 1 and VOR 2 are kind of active and listed there. So that's good there. So you can control those with these two switches here. So I'm going to leave them both on VOR just now. Next we need to set our altitude. So our first kind of altitude constraint, so to speak, will be 5,000 feet. So I'm going to dial that up to 5,000 feet there. And then next on the flight control unit, we want to make sure that all of the information and data here is dashed and has the little ball or the little circle icon next to it. So that puts the aircraft in managed mode. So that means that the onboard computers are going to manage the speed, the direction and the altitude. So very simply, to do that, you just left click on every button. It pushes the button in and you see we have dashed and the circle. so that means the computers are going to deal with speed, which is what we want. Do the same for heading, do the same for altitude. We don't need to do it for vertical speed because you can see that's already dashed out. Next we take a look at the ECAM just to make sure that we haven't had any unexpected errors pop up. So we just click on the status page there. It says normal, everything is good. And then the last couple of steps are just to make sure that the IRS has aligned, so your primary flight display and your nav display are all active and they're showing all the correct information. And then the final step is just to put your MCDU down to the flight plan page there. Okay, so after we've done all of those previous steps, what we need to do now is the before start procedure. So you may have noticed that there's one key component that's missing on the plane at the moment, and that is the passengers. So what we're going to do is we're just going to get those passengers loaded on just now and do a couple more steps just to get the plane prepared before we start the engines. Now, I'm going to run through the procedure on page 47, the before start procedure. However, I'm going to do things in a slightly different order, and I'll explain why as I'm going through. So I'm going to do all of the same steps that are in the documentation, but I'm just going to do them in a different order. So the first thing I'm going to do is I'm going to start by turning on the APU. So I'm going to start the APU for several reasons. Number one, the APU is going to provide electrical power to the plane, so we need it for that reason. Number two, the APU also provides a bleed air to the engines. So bleed air is the pressurized air that we're going to need to start the main engines. And three, it also provides heat to the cabin. So at the moment we're looking at the lower ECAM and the control panel here. So if I go onto the conditioning page here, you can see here that this is telling us what the temperature is within the plane. And you can see it's 13 degrees. That's a bit chilly for passengers. So what I'm going to do is I'm going to start the APU. And then what that will do is that will provide some bleed air, some heated air into the cabin just to warm the thing up before we introduce the passengers. Okay, so you can see that I've got a split view here again. I've got the lower ECAM display, which is on its default page while the plane is on the ground, which is the door page here. And what I'm going to do is, the first thing I'm going to do is turn on the APU master switch, which is just here on the overhead panel. So if you flick that on, that switches on the APU computers, and you'll see it automatically switches the ECAM page onto the APU. Now you just give the APU about 10 seconds, because what it will do is it will just, as I said, turn on the APU computers, and it also opens up the inlet flap, which allows air to flow into the tail of the aircraft and feed the small jet engine, which is the APU. So just give that a few seconds to warm up, make sure you've got the flap open confirmation there, and then hit the APU start button just down here. And you'll see the APU will start to speed up, ramp up, whatever you want to call it. So you just wait for that to get up to 100% on its end percentage there. The exhaust gas temperature usually comes up to about 700, slightly higher, and then it will start to fall back down as it gains speed there. And you see that as we hit 90%, you see the generator starts working. We start getting some information there. And then just as it hits 100%, all of the values fall into green, which means they're all working normally. And you can see that we now have, or we had, APU available at the top there. And also, if you have a look at the overhead panel, it says available on the APU start switch there. Okay, so now that the APU has started, what I've done here is I've switched the lower ECAM onto the conditioning page once again. And what I'm going to do is, if we have a look at the overhead, I'm going to turn on the APU bleed air. Now, if you keep an eye on the conditioning page, what you should see happen is you should hear some air conditioning fans kick in. You'll notice that the Pack 1 and Pack 2 fault lights went off. If you look at the air conditioning page now, you'll notice that the temperature starts to rise. That's because we're using bleed air from the APU to warm the airplane. So it's just a nice little gesture for our virtual passengers before we start getting them boarding. So the numbers in the sort of the icon of the plane there indicate what the temperature is set to, and the numbers underneath indicates the actual temperature that's going in. So you can see that will rise slowly over time. So now that we've got the cabin warming up nicely, what we can do is we can now load the passengers in. So if we go over to the second MCDU here, and then go into load and fuel. Now you'll notice here I've put in a random number of 120 for the passengers. Now normally on more advanced flight planning software it will actually give you a passenger number, so you would enter that in. The website that I used isn't too detailed, it just gives me a route and fuel estimation, so I've just put in a random number there of 120 passengers. And then what we can do is if we go on to the right hand side it says start boarding. Now remember that the passenger doors have to be open for this to work, so just be mindful of that. And then if you just hit start boarding there, you see we can have a maximum number of 180 passengers, and you see the actual passengers will start to rise there. So I believe that passengers board at a rate of about 1 per second approximately, so if you've got 120 passengers that'll take approximately 120 seconds, so it doesn't take too long. It might take maybe 2 or 3 minutes for passengers to load onto the aircraft. Alternatively, if you don't want to wait, you can just hit load instant and that will immediately put 120 passengers onto the plane. Okay, so while passengers are boarding the aircraft, there's a few other steps that we need to run through. So, first thing we need to do is now turn on the parking brake, like so. Next, we want to make sure that the thrust levers are in idle. So if we just zoom in quickly there, you can see that they are in the idle position, and the detent, or the little notch on the side of the thrust lever, matches up with the 0 on the idle position there. Next, we can set the barometric pressure here on the EFIS display. Now, I'm just going to be using the kind of the fair weather preset in FSX, and the barometric pressure for that is usually 1013 or 29.92. So I'm just going to leave that as it is. And then the last couple of steps on the overhead panel. First, we can turn on the seatbelt signs now that we've got people coming on board. So turn that to the on position. And the last thing to do is, now that we've got the APU running, is that we can turn off the external power. So if we just go to the external power here, right click on that, and it says now that it's switched off. However, it does say that it's still available, so that means that the generator is still plugged into the plane. However, we're not currently drawing power from that. And that's about it. So all we need to do now is just wait for the passengers to finish boarding. So you can keep an eye on the progress by looking over at the second MCDU here, and you can see that we're at 65 passengers just now. So just take a couple of minutes, chill out, grab a drink, and wait for that to finish. Okay, we've got our last couple of passengers just joining us just now. So that's all 120 passengers on board, and you can see that the boarding is now green and stops flashing. So that means that we've now got all of our passengers on board. So the last couple of things to do is just to sort of secure the aircraft and get it ready to leave. So what we need to do is we need to close all of the doors and remove all of the ground equipment. Okay, so I've just tweaked my view here so you can see a couple of external views of the plane, just so you can see things moving as I close the doors. And I've also got the ECAM page here showing the doors page, so you can see what happens as I close all of the doors and secure the aircraft. So on the second MCDU, what we do is we hit return to come back to the main menu here, and then if we go on to aircraft doors, first of all, we can close the doors. So if you keep an eye on this external view here, we're going to close the aft door first and then the front cargo door here. So back door goes first, you can see it closing, and then the front cargo door, and you can see it closing there. Next, on the left hand side of the plane, we're going to do the left hand passenger doors. So we'll do the aft door first, which is just out of view, and then we'll do the front door. And also keep an eye on the ECAM door page as well. You can see all of the doors disappear as we close them. So those are all of the doors secured. Now a few seconds will pass and then you should see slide will pop up around the aircraft. So that means that our virtual cabin crew have armed all of the slides, so all of the doors are locked and armed in the event of an emergency landing. After that, if we just go to return, now we need to remove the ground equipment. So just come back to the main menu again and then go into ground services. And then first we want to remove the traffic cones, so just hit the button next to that and you'll see the traffic cones will disappear. Next we'll remove the wheel chocks, these yellow blocks holding the aircraft in place. So remove those. And then finally we'll remove the external ground power unit, which is the little generator which sits at the front of the aircraft. So we'll remove that. And now the plane is almost ready for departure. So you can see there on the ECAM we've got slide next to our front exit doors, our overwing doors, and also the rear doors there. And if you also have a look at the overhead panel, you'll notice next to external power there, the available light has now disappeared because we unplugged the generator from the front of the plane. And then the final step would be to turn on the beacon lights, which will be this switch here. However, engine start, taxi and takeoff is something I'm going to cover in the next video. So I hope this helped, and yeah, look forward to doing the next video. So for now, thank you all very much for watching, take care out there, and I will catch you all later. Okay, so this is one website that you can use to set up a flight plan, and that is Online Flight Planner, and the website address is simply onlineflightplanner.org up there. So the way that you can set up a flight in this, you can see that we have a very simple website, very easy to use. So the first thing I would recommend doing is, if you're flying with the Aerosoft Airbus, would be to tick this box here. So what will happen is, once the flight plan has been generated by this website, it will give you several file formats that you can download the flight plan. And if you choose this one here, FLP or Airbus X, then what that will allow you to do is that will allow you to download the flight path into the Aerosoft, so you can use it as a kind of a preloaded route, for example, so you don't have to manually type in every waypoint and every airway, for example. So to set up your flight plan, first thing you can do is just set in your departure destination. So this is the departure airports. So for us, we're going to be using EGGW, which is London Luton there. So you see it comes up there, just type that in. And then our destination will be EGPE, which is Inverness. Now this allows you to choose the AIRAC cycle, so if you've got a particular nav data set that you want to use, you can select it from the drop down here. The Aerosoft uses 1511 however, if you use a nav data service, then you might have more up-to-date cycles of data, so you can use whichever one is most applicable there. I personally have 1511, so I'm going to use that for this, but obviously if you've got something different, then you can use that. Next you have the altitude range, so you can generally choose which altitude range you want to fly within. Generally Airbuses, in my personal experience as a passenger, will fly somewhere between flight level 3.1 and flight level 3.9. Here you can choose either low altitude airways, high altitude airways, or both, so we're going to be using both. And then the aircraft here, now here it has like general aircraft makes and models. It doesn't have, well, there's a couple of specific ones here, like you have the Boeing 747 for PMDG, you got a 737, you've got the iFly and PMDG specific ones here. There doesn't appear to be any specific to the Aerosoft Airbuses, so I'm just going to choose Airbus A320. And then fuel units, depending on where you're flying in the world, you can use either pounds or kilograms. So because we're flying in Europe, we're going to be using kilograms there. And then simply hit create plan. It'll take a few seconds just to generate the flight plan there. And then you see the page refreshes here, and you've got a bunch of waypoints. So the information that you can use within the simulator will be this here. This is what you're looking at, will be the airways. So you can see we're starting at Luton Airport, EGGW, and then it says SID. So obviously, depending on the weather conditions, you'll need to choose which runway you'll be taking off from and the appropriate departure procedure for that runway. And then you can see the first waypoint here will be Olney. And then you see it gives us the airway from Olney, which will be T420. And then the next waypoint will be Welling. And then it gives us airway, waypoints, airway, waypoints, until we reach Findle. And then it says star, and then down to EGPE. Now, if an airport doesn't have a star or an arrival procedure, then what you would usually do is fly directly from the last waypoint down to the first or the start of the approach for the runway at your arrival airport there. Now here it does also give some METAR information, so if you know how to read METARs, you can choose your runway departure and arrival runways based off that information there. And then underneath that, more importantly as well, is you have the fuel estimates here. So you can see the fuel usage for the flight will be 3,081 kilograms. Gives us a flight time of 1 hour and 16 minutes. It gives us a reserve fuel amount as well of 3,040 kilograms or 1 hour and 15 minutes. And then fuel on board. So this will be your block fuel. So this is what you want to load into the plane. And you can see here that it gives us an estimate of 6,121, which gives us a total flight time of 2 hours and 31 minutes. And then just underneath that, you can see it gives us a little map of our route there as well. So we're taking off just north of London, and then we'll be flying sort of northwest, kind of up the spine of the UK, and then straight into Inverness.